Hi, I'm Tom Lieb from SCAT. Today we're going to talk about the LS crankshafts and the LS engine program. And the LS cranks, of course, because the LS engine was a completely new design, GM went through several configurations before they've settled down to where they are today. And what that's done for the performance side of things is that we have to have parts available for all the different cranks. And what we have here, one of the first things that they did is they went from the 6-bolt flywheel to the 8-bolt flywheel. The next thing that happened was with the reluctor wheels. This is a 58 tooth. The 24 tooth, which is the early models, is a 2-piece, and both of these are the later configuration, but without the proper reluctor wheel, of course your engine isn't going to run. So that's on this end. On the other end, as we work around the table here, on the other end, they've gone with different length noses and different configurations as far as the steps. And that's because of the variable cam timing, the LS7 with the dry sump pump, the LS1 with the earlier design on the nose, and that causes problems. And the most popular crankshafts for the performance side of it, the stock stroke is 3.622, and the most popular stroke increase is the 4-inch, and then to go one step further, like in the LS series engines at GM, which we furnish the cranks and rods to, that's a 4 1/8 stroke crank. The real Achilles heel with the LS engine is that it's an aluminum block, and the tensile strength of the aluminum block is 34,000 pounds. The tensile strength of a forged crankshaft is 145,000 pounds. So what happens is the crank ends up being the strongest part in the engine, and it goes to hold the whole thing together. And the counterweights on the crank, however, the original cranks had only 6 counterweights, so it had no counterweights in the center. So the 2 center throws have counterweights only on one side, which caused the crank to do this. What we've done is we've come up with a new forging for the high horsepower and so forth, where we have the center counterweights. So you can see here that the center 2 throws now have weight on each side to prevent the crank from doing this in the engine itself. And of course, because it's a center thrust, when it does that, it grabs the center thrust bearing, which poses a problem. So this is the real new thing that we've done, and probably the most significant as far as the reliability of the engines, especially when you start putting more horsepower and RPM in them. Now, after we've done all that, then the problem becomes when you put supercharger, turbocharger, or you decide to run nitrous, then what happens is you end up with a connecting rod that has a problem. The connecting rod, the weight of a connecting rod and the strength of the connecting rod is in the center beam. So this is a standard rod that we've had. What we've done is we've come up with a heavier rod, which is in my right hand here. And if you notice the machining here, we've got more material in it. We've got a generous radius. The width of the web is thicker. But in doing that, what we've ended up doing is adding weight to the connecting rod, which causes problem in balancing, where the LS crank doesn't have the thick counterweights that the small block 350 has. The LS has thin counterweights, and balancing is an issue. To solve that problem, what we've done, and this is kind of a neat little thing, and it's very simple. What we've done, this is the I-beam rod. This is typical standard LS connecting rod. And you notice here, directly over the big end, there is no material. There's no stress in this area, but when we go to machine the rod, because we come through here with a slab cutter, we end up with a triangular piece here that is solid metal, which is not in an I-beam rod. So the way to take care of that, very simple, we drill a hole. When we drilled that hole, what ended up happening is the 50 grams that we put in the extra strength of the rod, we took out 40 grams in 2 rods by drilling that hole, which meant that the balance comes back and we don't have to add extra Mallory. Extra Mallory means we've made a savings as far as the balancing is concerned. So basically, very, very quickly, we've gone through the progression and the development of the LS engine at SCAT and how we have the parts to meet all of the needs of the customers. Thank you very much for listening. You can contact us, www.scatenterprisescrankshafts.com, or if you have a technical question, it's www.scatcrankshaftstechline.com. And we have, of course, a whole series of people on staff that can answer your questions and take you through the technical side of things, and of course, write up the order. We appreciate that. Thank you for listening.